I'm Ray Loy. I'm the Deputy Director for the program this year, and I'm also the ALCF lead for training debuggers and math libraries. And I'm going to give you really what I would call a crash course in starting on the machines that you have available to you for these 2 weeks. Just to bear in mind, for the ALCF machines alone, the getting started material is about 3 hours worth, and that's the quick version. So this will be a very quick summary, and I'll point you, there are links in the slides to the longer version of the quick start and various other materials. So you should be able to, the goal of this talk is to just have an idea, general idea of what is going on so that you can at least get a hello world program running on a few machines, and then you can copy scripts and for examples, and at least you have the resources to look. So I'll briefly cover the ALCF systems, which include the new machine Theta, which is Knight's Landing, the slightly older machines, the KNL, the Blue Gene. And we also have an x86 GPU cluster available for both data and learning activities as well as post-processing and visualization. Marta mentioned the JLSE, and we have the Oak Ridge resources, Titan, and the NERSC resources, Cori and Edison. So you can use all of these machines. So you've heard the term leadership computing bandied around, but what does it really mean? The intent is to support large-scale runs, not lots of tiny ones. So within DOE, one of the first sites was NERSC, and they support what we would call capacity computing, whereas they have a lot of machines, but they don't expect people to run larger than small node counts. But first, the Oak Ridge Leadership Computing Facility, and then following on, Argonne's Leadership Computing Facility. We focus on providing to any given project about 100 times more compute hours than a project at other sites. So our goal is to support fewer projects but much larger to enable scientists to do these grand challenge type problems. So the three primary systems, Argonne is in a bit of a transition on its way to Aurora. We have the Theta KNL machine and the Mira BGQ machines, and Oak Ridge has Titan and is working on Summit as we speak. And do they have access to Summit yet? Yeah. Okay. And Jack will be talking about that later. So within ALCF, I mentioned these machines already, but just a little bit more detail. The Theta is the Cray XE40 with the Knight's Landing processors. And Mira is the largest, the large production BGQ. The additional BGQ systems, which are smaller, are Vesta and Cetus. So Cetus is effectively the debug queue for Mira. So when you need to run smaller jobs, then you would fit into the queue policy on Mira. You would do them on Cetus because Cetus is on the same file system. The software stack is identical, so you can do your test runs there and then just submit to Mira. On a separate file system is Vesta, another BGQ system that has 2K nodes. And that one has the advantage for debugging that the minimum hardware partition size is smaller at 32 nodes versus 128. And the Cooley system, which, as I mentioned, can be used for visualization and data analytics. It has Xeon Haswells with Tesla K80 GPUs, and that's accessible from either Theta or Mira or Cetus from those machines. So JLSE. Previously, I was talking about machines in Argonne's leadership computing facility, which is the user facility. The JLSE is an internal resource for testbed systems that are worked on by both the leadership computing division as well as the math and computer science division. And these tend to be smaller, but in sort of cutting edge areas. So there's a lot of transition, a lot of turnover. We're always adding something new. You know, there might be, you know, we just recently announced an Apache system, and there are other things like ATPESC quantum simulator and so forth. These are not meant to be big production systems. It's meant to be a test bed. Usually you would get access to these by having some sort of a collaboration with either LCF or MCS people, but you can check it out, and I believe you're going to be using one of the systems tomorrow for FPGAs. And the help email is different from it's not part of the user facility, so the help email is help@jlse.anl.gov. Okay, so I'll move on and talk about, in more detail, Theta. So Theta is our bridge between the BlueGene-Q Mira and the upcoming exascale Aurora system, which will have a new architecture, which is not fully public yet. So the Theta system is a Cray XC40 officially, and we expanded it a little bit since its initial installation. So it's now at over 4,000 nodes, and each one has 64 cores, and each core can handle 4 hardware threads. One of the special things about it, besides having the KNL processors, is that it has 16 gigabytes of high bandwidth memory on each node. And if your application fits in the high bandwidth memory, you can speed it up quite a bit by taking advantage of that. There are also SSDs on each node. You do have to make a special request to access those, so just to be aware. And the machine is connected with a Cray Aries in a Dragonfly topology. So your file systems, there are 2 file systems. The GPFS file system is what we use on the BlueGene-Qs, and it is mounted on Theta as well. So your home directories are common between the Mira, Cetus, and Cooley and Theta all have the same home file system. Vesta's on its own. So the project directories on Theta will be in Lustre. So there's a separate path. So for example, the project directory for the ATPESC project is /projects ATPESC 2018. That's in the Lustre file system. When I talk about BlueGene later, the BlueGene projects are in GPFS. So just so you know where stuff lives in general. Theta uses modules to set your environment. If you've used other sites, most other sites use modules. You are probably familiar with the commands. You can say module list to see the packages that are available. This is a difference between Theta and the BlueGene systems at ALCF. The BlueGene systems use something else. I'll come back to that. Compilers, the most important thing to know is that you should not use MPI-CC and MPI-XLF. I'm sorry, MPI-F90. I'm crossing my thoughts with BlueGene. But MPI-CC you would think is what you'd use for MPI, but that's actually the front end compiler that's by default set up for the login nodes. What you want to use, what the both the Cray and Intel programming environments and modules set up is to use just CC and FTN. So use those. Don't use the other one. It's not going to work. It will be confusing. So if you, by default, you'll get the Intel software stack. You can confirm that by doing a modules list. If you want to switch for Cray, GNU, or Clang, you can do that. And so the names of the modules are here. Here's a simple job script. So the important thing to note is that we're using Cobalt and not PBS. So Cobalt is somewhat like PBS for queuing, but it's not quite the same, but there are a lot of similarities. And in a PBS script where you would include directives such as #PBS at the top to include your options like the queue name or the time or the number of nodes, you would use #Cobalt here. So in this example, it asks for 10 minutes, -T10, 2 nodes, -N2, and your project name, that's like the bank account that you're going to bill against, is ATPESC 2018. And then Aprun starts your job, just like on other Cray systems. So here's a little translation key of the Aprun arguments sort of translated into real world things like the number of ranks that you want, the number of ranks per node, right? So don't mix up small n and big N. And you have the concept of depth, right? If you look up the man page for Aprun, depth will talk about the number of CPUs per rank, but you need to translate that to mean the number of hyperthreads per rank, depending whether you have turned that on or not. So generally you wouldn't. In the simple cases, you'd like to select CC depth. Depth is a keyword. It's not a number to replace. I put it in. Does the pointer show? Yes, it does. Okay. And so anyway, and there are some example scripts and runs, programs that you can try that are in the supplemental links. So you'd submit a job using QSub, and pretty much the same way as with PBS and your job script. So you can either specify your options on the QSub line, or you can put them in the job script. If you put them all in the script, then you can just say QSub jobscript.sh. So I think it's better to put everything you can in the script. That way there's a record of it. So if you don't specify queue, you'll get the default production queue. You may want to, so for most sessions here where we've reserved nodes, the name of the queue will be training. That'll appear on a different slide as well. So, and then just in general, outside of this ATPESC, you probably, for small tests, you'd want to use one of the debug queues. So they're called debug cache quad, debug flat. QStat tells you what's going on with your job like you'd expect. And after your job starts running, and at various stages, these files will show up. You'll see a file that's something like 123.cobalt log, where 123 is your job number. So you do qsub job.sh, and it'll spit out the job number. And you'll see that 123.cobalt log has been created. And then when the job actually starts running, if it does, you'll see 123.error is the standard error for the job. 123.output is the standard out. For debugging, which you're going to have problems to start, you probably want to start an interactive job. So the capital I option gives that. So if the minimum you can give is I, number of nodes, the time. So in this example, 32 nodes, 30 minutes, the training queue, and the ATPESC project. And you don't specify a job script because it will it will put it in, and then when you get to the front of the queue, you'll get a shell to run at. So when you get that shell, you could actually just run your job script that you're trying to figure out, right? Because those are the same commands that you would want to execute anyway. So it doesn't have to be you don't have to sit there and type them. You could actually just run interactively your job script. And there are some environment variables you'll see set there, such as Cobalt job ID, that either you or your script can examine and use. And you should note that when you're doing interactive jobs that your shell won't just get killed when the job time is over. So if you submit an interactive job for, let's say, 15 minutes, and 15 minutes elapses, the job is gone, but your shell is still there. The reason for that is that we didn't want to, if you were editing something or something like that, we didn't want it to just get killed. So it's a little hard to give a message about that. So there's no warning that that happens. But if you're past your time, when you go to do an app run, you'll just see that it fails, and it'll say you don't have permission to use the resource or something like that. So if you're not quite sure what's going on, what you do is just do a QStat on the job ID, and if you get some output saying, the job has been running this many minutes and it has this much time, right? The job is still alive. If you get no output at all, that means your job evaporated, right? It's already gone. So that's how you can tell what's going on. Okay, well, it's inevitable that things might not work right. So you might get a core file, would you get a core file, right? So the problem is on 40,000 ranks or something, you can't dump binary cores, right? So the machines have different strategies to deal with that. On BlueGene-Q, you'll get these lightweight text files that have the core information in them, and on Theta, what happens is that you can generate a merge stack backtrace that's in the form that a tool called stat can display. And so in order to get that backtrace, you need to enable the dump, so that what happens is at the end of the run, when it exits abnormally, this piece of software called abnormal termination processing, it's a Cray hook. It will get them all to coordinate, all of the ranks to coordinate about where they are, and it will generate this file that you can, the default name of it is ATP merged BT. BT is backtrace.dot, and then you can use a program called StatView to view it. So there's a little bit more instructions in a presentation I made in our last workshop, and there's a link to that URL there. So, okay, so I'm done talking about Theta, the very, very quick version of how to use Theta, and now I'll talk about the BlueGene. So Mira, the big one, once again. Cetus is the debugging one for Mira, and Vesta is the smaller test system. So Theta used modules. The BlueGene machines and Cooley use something called Softenv. So Softenv likewise sets your environment, your shell environment variables to reasonable values, but it is a completely different system to do that. And it uses keys in a file in your home directory called .soft. Now, because the home directories of the BlueGenes and Cooley are the same, and Soft doesn't understand how to have some keys relevant to some systems and not others, the soft file for Cooley is in .soft.cooley. So if you're trying to make settings for like the compiler or to add a debugger to your path or something like that, and you're working on the BlueGenes, you want to modify .soft, and if you're on Cooley, you want to modify .soft.cooley. And when you're editing this file, if you see something, some of the instructions, it'll say add this key to your .soft file. After you edit it, you'll need to type the command resoft or to log out and log back in, whichever happens to be the more convenient thing, in order for it to reread the file. But make sure that when you modify it, you don't remove the at default that's at the end of the file, because if you remove that, you'll lose your normal path settings that you won't be able to access, cat and ls and things like that. It'll be, you can recover from that, but it's a little tricky. Okay, so what compilers are available on the Blue Jeans? Well, the XL compilers traditionally were the best thing. However, Blue Jean is a legacy system now from IBM, and they haven't been updated in quite a while. So for Fortran and regular C, that's not a problem, but if you're using some newer C++ features, it can be a problem. So if you're using the Blue Jean system and you need some robust modern C++ compiling, you probably want to look at the Clang compilers. The GNU compilers are not quite as old as the Blue Jean, the XL compilers. However, they don't support generating code for the quad floating point unit that the Blue Jean processor handles, and Clang can, at least under some circumstances. So your best bet for C++ is Clang. Here's an example job script for any of the Blue Jean systems. It's also Cobalt, just like Theta was. However, the difference is instead of using Aprun, which is kind of a Cray thing, you use a command called run job. And run job takes P is the number of ranks per node. NP is the number of total ranks. And block, you need to include this block Cobalt part name. That's set in the environment automatically, right? You're not supposed to replace that with something. In other words, when your job script runs, that's set in the environment to the location that your job was allocated. So you would put that in, and it's important to note that the colon here is actually a lexical token. It needs spaces on both sides of it. You can't munge this together or it will not parse it right. So think of it more like a word than a piece of punctuation. And I think I made notes about this down at the bottom. Okay, you submit with qsub just like on the other, on Theta. And likewise, you can run an interactive job on the Blue Jeans, but let me just mention that you can't, on both systems, both Theta and Mira, when you run an interactive job, when you get the shell prompt in the job, you're not actually on a compute node in either case. So just be aware of that. So on the Blue Jean, you're really on another login node that was dedicated for this. Because Blue Jean compute nodes can't run a shell. That's a part of the limitation of the lightweight kernel that's on the thing. So just be aware that you're not actually on the compute node. You're on a login node with that interactive shell, but you have compute nodes allocated to you, and those are named in that in the Cobalt part name variable. In the case of Theta, I should have mentioned that while you could theoretically get a shell on a KNL node, you don't really want to. So what it's set up to be is you get a shell, when you're in the interactive job, you get a shell on what's called a mom node, which is sort of like a service node that's part of the system to shepherd the compute nodes. So on the blue gene, after you do get that shell prompt, though, when the job runs, you're not quite ready to run yet. You need to wait for the compute partition to finish booting. So it would be nice if this happened automatically for you, but there are some technical issues with it. So there is a program, a command that we've installed called wait boot. And wait boot will just poll the status of your partition until it's ready to run. So if you were to do a run job command before it's ready, the run job command would fail. It would say that the partition's in the wrong state or something like that. So just follow the list. And you have the same issue on the blue gene as on Theta. If your job runs out of time, your run job will fail. So do a qstat on the job ID and you'll see whether it's still alive or not. So because blue gene has a torus routing, as well as the compute partition, the compute nodes are organized into groups attached to I/O nodes, right? So the I/O nodes in the blue gene architecture, I didn't have time to describe it all in gory detail, but essentially there are I/O nodes embedded in the system that each are in charge of a set of compute nodes. And those two factors between the torus and the I/O node size determine what units you can boot independently in the machine. So Vesta has more I/O nodes per compute node than the other machines. So it's possible to, physically possible to boot 32 nodes into, as a group, whereas you can't boot that size on Cetus or Mira. On Cetus and Mira, that ratio is 128 compute nodes per I/O node. On Mira, the reason why you can't boot just 128 is actually a queue policy issue because it's a production machine. And if you think about the number of 128 node partitions in a 40 rack system, it's pretty large, right? So we want people to be running, eight rack jobs minimum. So the queue policy requires a minimum of 512 nodes in a job, except for reservations, special circumstances. So you can't run anything as a normal single job that's smaller than 512 nodes. Okay, just a little bit about the node architecture on the blue gene. There are 16 cores. Each core can run 4 hardware threads, but at the time that you start the run job, there's a number that is the number of ranks per node. So essentially what you're doing is you're saying how you want to divide up those 16 cores, right? If you say that I want 16 ranks, MPI ranks, then you're going to get one core assigned to each rank. If you say I only want 8 ranks, then you're going to get 2 cores assigned to that rank. And unless you're threading, that's not really going to help you. But if you have hybrid code where you're doing OpenMP, MPI plus OpenMP, then you have now, instead of having 4 threads available to that one rank in the 16 ranks per node mode, if you only have 8 ranks per node, then you can run twice as many threads, and so on. So there's more info about that in the Mira Getting Started presentation. And speaking about OpenMP, this is an example of where you would set the OMP num threads value on the run job line, the environment values, right? In all of these cases, the environment variables are not generally passed into the running parallel job unless you explicitly list them on either the run job command here or on Theta in the Aprun command. So keep that in mind. And there are a couple of caveats about compiling with the Excel compilers for OpenMP that you need to enable it with QSMP equals OMP. And you may or may not need to increase the default stack size. Okay, moving on to Cooley, the x86 GPU cluster. So here's an example of a job script for Cooley. Now, this is Cobalt, but it's a slightly different flavor of Cobalt because Blue Gene, let's face it, is a pretty specialized environment with the way the compute nodes run. Cooley is more like a traditional Linux cluster, right? So when you run a job, your head node of the job, so to speak, one of the nodes that were allocated to you will actually run the job script and get the other ranks started up. So it's probably a more familiar situation to what you might be used to, unless you've used one of the leadership systems. So it's a little bit different. This is the so-called cluster version of Cobalt, and you would use MPI run here instead of run job or app run, and you need to reference the node, the file with the list of nodes in it that Cobalt will give you, and you can just use this as an example. So there are example programs and scripts in the links. Okay, so looking at the bigger picture for ALCF resources, the project name that you'll use to run on any of these machines is ATPESC 2018. And remember to enter, when you have your fob, but you need to enter the PIN that we gave you before you type the code that shows on the token. And if you need any help with anything, email support@alcf.anl.gov. And probably would be a good idea to mention ATPESC even in the subject so that we can try to give quick turnaround on these for you guys since it's a special event. And the reservations that we set up in general will use the queue name called training. Right? So use training. I have some tips here about using your Cryptocard. If you try it once and you don't get in, I would suggest don't press the button again, just type it again, because the odds are that you may have just typed it wrong. It doesn't know. If it didn't have a match, the other end doesn't know that it's not marked this code as being used, right? The fob and the other end, the server, have a moving window of codes, and until you actually authenticate one, it doesn't advance the window. So if you, that's what I would recommend, to avoid getting your token too far ahead of the server. And I would say if you can't log in twice, then it's possible there could be something wrong with that machine. Try logging into a different one, because if there's a transient issue with one machine. Because as soon as you have a successful login, it resets your failure count and it avoids getting blacklisted from either your IP. So the very first, this is actually an amusing story, the very first ATPESC, we didn't anticipate the fact that, well, with 60 plus people in the room, it would bound for a few people to accidentally type the wrong password. And then we got the whole, the IP for the site blacklisted. And so we have this down, after 6 years now, we've got this. It didn't take 6 years. So the second year Adam took care of everything, and it was smooth sailing after that, but it was an unanticipated problem. So there are web status pages for all of the machines. I'm just showing one for Mira here. And because of the Blue Gene kind of fixed partitions of the partitions that you get to run jobs in are in specific physical locations. So they show up as nice solid blocks of racks that are allocated to your job. In a machine like Theta, they, it'll all looks more like a scatter plot. Okay, so where to go for more info? I've linked into the projects directory for ATPESC, projects ATPESC 2018 on all the machines. You can take a look in there, and either within there, ALCF Getting Started points to 2 slide decks and sets of I didn't drop the slide decks there. The slide decks are linked at the bottom of this page, I'm sorry. But what's linked in the file, in those directories, are the example codes of scripts and just some simple programs that you can see how to compile and build. And one thing, if you're doing threading, especially on Theta, there are some examples of how to specify the options for Aprun, for affinity, of how to lay out where the ranks are on each node and stuff like that. So there's some examples there that you should look at. So just take a look at the slides and then the example codes that are linked here. And then our main set of online user guides is at user guides. But if you want the quick version, flip through the slides. The Theta Cooley slides are about the size of this presentation, but only about them. The mirror ones are probably about twice as long. So what other resources besides Argonne? There's OLCF Titan. The project name there will be TRN001. And after I speak, I'll let Jack from OLCF speak for a few minutes about that, so I won't dwell on it. From NERSC, Edison and Corey are also available. The project name there is ntrain, and here are some links to their user documents on how to get started. So I'll just mention on Theta, right, I mentioned the high bandwidth memory. There are 3 different modes that you can run jobs in, and usually people start using cache mode, and what that does is it uses the high bandwidth memory in the node as a cache, and when that fills up, then or you have misses, it goes out to the regular memory. There are also ways to put it in flat mode where you explicitly reference allocating things in either the high bandwidth memory or the regular memory, and that is faster, right? Because you don't have to have the whole cache miss process, but it takes a little more work coding. And then the hybrid mode can allocate some to one and some to the other, but that's a little trickier. So, but anyway, you might, if you have a well-defined memory usage and allocation, you might consider looking into the flat mode. But the way you change this mode, it has to be specified, it has to be done when the node is booted. So the way you accomplish that is that you have to specify it as an attribute on your job, because the queuing system needs to reboot the nodes. So there are some instructions on how to do that. It's an attribute of the job with this ATTRS setting. And the debug queues, right, one of them is called debug cache quad, and the other one's called debug flat. And those nodes are permanently in those modes, so when you're in the running small debug jobs, you don't have to wait for this reboot. Okay, so I'm going to turn it over to Jack Morrison from OLCF. Thank you.
All right, so I promise I'll be brief. My name is Jack Morrison, and I wanted to quickly kind of introduce myself and also introduce Titan, the Oak Ridge Leadership Computing Facility resource that you'll have available for the next couple of weeks. I'm not as interesting as Titan, so we're going to go ahead and move past me. But But quickly, I wanted to mention, I think there are a number of you who already came and picked up a training token. This will get you access to that system. If you haven't picked one up yet and you're interested in running on Titan, I will be here for the duration of the event. You can catch me in the hallway. I'm happy to give you one, or also be in the office. We can set these up for you, no problem. And the one thing I would ask is you hang on to the little envelope that you get with it. We'll ask for these back at the end of the event. So Titan, you've probably heard of Summit. Unfortunately, I can't give you all Summit access for the next couple of weeks, as that system is still under acceptance testing. But Titan is the OLCF's current large production system. It is a Cray XK7. I'm not going to go into the particulars of the system. I'm kind of going to high-level overview it and say if you're interested in running on Titan, go check out all of our resources. But it's got a hybrid architecture. Each compute node, each of the 18,688 compute nodes, has a 16-core processor. And importantly, it also has an NVIDIA Kepler architecture K20X GPU attached to it. So between the two, you get, let's see, where is it? You get 32 gigabytes of memory associated with that CPU and another 6 associated with the GPU. That is as high level as I could keep it. So it's my understanding that the OLCF resource is a little bit secondary. There are a lot of resources, a lot of facilities that you all have access to run on. Titan is here kind of at your disposal if you would like. You have a separate training allocation. We don't have a reservation in place, so if you submit a job on Titan, you're going to have to wait in the queue. Sorry about that. But I do have a number of links here I just want to point out. We do have user guides like all the other facilities, so the Titan user guide you'll find right here. And then just in the last couple of weeks, we also ran an on-site training event, and you can find a recording and slides of several things to kind of get you going, you know, in all of your free time here, if you want to learn more about Titan. Here's some places to start. So there's quite a bit of information on our website. If you doubt that any of it is up to date, these are the most recent training materials that we have. So with that, I'm finished here. I don't know if, Ray, do you have anything else to say?
We have about 10, 15 minutes before dinner. So what I'd suggest is try to get on, just pick a machine, try to get on it, and just compile one of the Hello World programs or something, and see if you can get it to go. At least you'll get a head start on tomorrow. So.
On that note, since we do have some time, if you haven't picked up an OLCF training token and you would like one, please come see me.